Hi everyone, my name is Yiğit and I'm here today with Elif and Danny. And we're going to talk about our Kotlin multi-platform journey in Android X. So let's just to put everyone on the same page. Kotlin multi-platform is a way to write Kotlin code, the one we love, and target multiple platforms. So you can write for Android, write for iOS, Windows, web, whatever. And if you're not familiar with the Android side of things, on the Android side, we have Jetpack, which is a suite of libraries and tools to write better Android applications with ease. So if you think about it, Jetpack is all about Android. That's what we care. And Kotlin multi-platform is about all platforms. So if you get the intersection of these, you would think that Jetpack has nothing to do with KMP. And if it was that simple, we wouldn't be having this talk. So ideally, it's not. If you want to look at it in a little bit more detail, our goal is to make Android successful. So what makes Android successful? We want to have a successful ecosystem. By that, I mean like you can create applications that will delight users. You can create profitable businesses. We all need to make money. And then it's also good for your careers, right? As a developer or an engineer or a product person, if you invest in Android, you want to make sure you can reuse those skills. And if you look at what Kotlin multi-platform brings to the table, it actually has a very positive impact in these areas. So the native interoperability in Kotlin multi-platform means that you can take advantage of the existing platform to the fullest without limitations, unlike some other frameworks. It reduces the amount of code you need to write. That means you're faster to the market or you have more time to spend on increasing your application quality. And then finally, as a developer, once you learn Kotlin, you can actually reuse that skill in other platforms. That means you're not just an Android developer, you can be a web developer, you can develop for other platforms. So that's actually really good for our ecosystem. So even though Jetpack is about making Android better, when you combine Jetpack with KMP, we do get better Android. So basically our goals align. And this is the reason why we have been investing on Kotlin multi-platform, and that's the reason why we will keep investing in Kotlin multi-platform. But that doesn't mean we're going to just convert everything to KMP. And that's also not the case. Like, first of all, like we have more than 800 modules, like hundreds of libraries. It's just impossible to convert all of this to Kotlin multi-platform. Also, you don't need to convert everything to Kotlin multi-platform. Like we have libraries like Recycleview. If you're familiar with Android development, you don't really want it on the web or iOS. You just don't need it anymore. And also, Jetpack is really old code base, 10, 15 years old. We have a lot of CI infrastructure that's built for Android. We know how to build Android libraries. And every time you add a new platform, we have to rethink a bunch of things, like from CI to linting to testing. It might be normal for an application company, but for us, all of this is new. So once we start thinking about web, we don't know any of the best practices, so we need to build all those skills. So every platform actually costs us a lot of time. As a result, what we try to do and what we have been doing is like slow but steady progress. So we experiment, we learn, we expand, we learn, and we expand. And we think this is the right way to go. Instead of trying to do as much KMP as possible, we try to find the places where we will have the most impact and focus on that. So how it has been going is actually like we have been looking into KMP for more than 4 years, for 5 years now. I was looking at the documents we have. So we did the very first Kotlin multi-platform product review in January 2020. So at Google, once you want to propose an investment, that's what you do. You create a product review of how you have evaluated this technology. So we evaluated Kotlin multi-platform and we thought this will be good for Android. So we did that. you keep doing it until you can get it funded. But then by next year, coincidentally, we realized the workspace, the group at Google, which owns apps like Gmail, Google Docs, Google Calendar, they were also looking into KMP. So we're like, okay, let's work together. And we've been creating a lot of experiments. Like we just write random Kotlin multiplatform code, run them through benchmarks, tries to see how it's going to work. This is like, we are trying to validate if KMP is good enough. After a year, we started feeling better about it, and we shipped these dev libraries to the public. That's when we said, okay, we think KMP is going to work. We know there's still a lot to do. I mean, even today, there's still a lot to do, but we think, okay, this technology has a feature. So we started sharing with the ecosystem our dev libraries, which is like libraries you can use, but they're not really supported, and they're probably broken, but you can use them. And then finally, last year, we achieved another milestone where we started publishing alpha libraries on our Maven repository, and we started publishing documentation. Now, this might look very simple from outside. Internally, it's a huge effort to convince everybody that our developer website needs to have documentation about other platforms. So this was actually a very big commitment for us. And now finally, this year, we are at a place we know that KMP will be here to stay, and we will keep investing on it. That means you should too, or at least consider. So what does that mean? Like, what are we working on? Actually, for us, still a lot of the work is on the infrastructure side. Like, we take binary compatibility very seriously, or semantic versioning. And then we don't have those tooling available on iOS side yet, or for native yet. So we have been actively building them to make sure when we ship a stable version, you can actually keep using it and it's not going to break in the future. I want to expand the platforms we support. We especially want to expand the WASM and then maybe more platforms afterwards. But again, because we have to build everything from scratch, that takes time. We are focusing on external tooling. If you have realized recently, we have shipped this Android Gradle plugin, Android Gradle Kotlin Multiplatform plugin, which is these two plugins used to conflict a lot. So now we have one plugin that sets up both of them, and so they don't conflict. We are trying to make sure Studio loads KMP projects properly. So it's like all very basic stuff, but they are what defines the quality of developer experience. So they're very important from our perspective. Of course, finally, libraries. This is what we mostly do. We have been playing with these for a while. We have annotations, collections, and data store ready to that you can just use them from iOS. Now, we have been also commonizing some libraries. I know there's some confusion about these. Like earlier in the keynote, we called them alpha, but they actually have stable versions, but they're not the same as the other ones. Basically, what we are trying to do here is, we think like libraries like lifecycle, vModel paging, they are usable. They should be usable on iOS and the web. But we don't necessarily have all the components ready to use them. So what we do is we commonize the code so that you can either manually combine it with that target ecosystem or use another library that already does it for you. Like I know now the KMP vModels supports our vModels. So it's when we just commonize something. And then finally, actually, like the most requested library we had was Room. I was here in 2019, December, we had Kotlin Conf in Copenhagen, and that's when I was getting the question, are you guys going to make Room multi-platform? I'm like, I want to, but there is no way to process Kotlin code, no way to generate Kotlin code. Like we are so far from it that even if you want it, you cannot do it. So I'm so happy after like 4.5 years, we did it. So we're gonna talk about it. Elif, go ahead.
Okay, well, hello everyone. Danny and I make up the entire gigantic Room team. And we work on Room, and today we're gonna talk to you about our journey to multi-platform. So before we dive into the entire journey, for anyone who hasn't gotten a chance to try out Room yet, Room is a Jetpack library that makes it so much easier for you to use SQLite databases in your applications. through its annotation processing APIs that generate code. So how would you set up like a very simple room database? Let's go through an example. Let's say you want to do a music database, very classic example, and what would you need? You would need something like a song table, an artist table, stuff like that. So how do we represent this in Room? Well, we use data classes. Let's say we have a song data class, and we want to have it be a table in our database. We have some columns that we represent in properties. So let's say we have a song ID and a song title. And how we tell Room that this is going to be a table is we do this by annotating. So we annotated with the @entity annotation, and now Room knows that this is a table that's going to go in our database. So for a more complete example for a music database, let's say we have 2 more tables, an album table and an artist table. So how are we going to use these tables? How are we going to access them and do processes on them? Well, we use these things called DAOs, or data access objects, which are interfaces or abstract classes that house functions that you define to perform database operations on your Room database. So how will we set up a DAO? Well, we start, like I said, with an interface or an abstract class. We annotate it with the @DAO annotation, very important. You don't forget the annotations for an annotation processor. And then you start adding some functions that you want to use, maybe like a very simple, basic insert. Obviously, you insert things to a database if you want to read stuff from it. Or you could do something way more complicated like this, a very complicated select statement, and Room will actually take that statement, it'll verify that at the compile time for you so that you don't make any mistakes with your SQL statements. And the really cool part about having all of this DAO functions is that you can actually transform your query result into a very handy data structure or something else. So we have a flow that's getting returned here. You could have a list, you could have an array, you could have maps. The sky's the limit. Not really, but check our docs. And you're ready to do things on your database. So let's put all of this together and actually define the database. That would be helpful. And we start out by an abstract class, music database, that extends the Room database class. And then we annotate it, once again, super important. And then we, within that annotation, tell Room which entity classes we need to include, so that it knows which tables we're going to have. Set the version, extremely important. And then you add a getter for your DAO. And then at that point, you will be able to give Room enough information to actually generate this database implementation for you. So originally, Room was an Android-only library. But now, with the KMP support that we've announced very recently at the start of this month, we can now support JVM desktop as well as native in addition to Android. This is super easy, said and done. Sounds really cool, but it was a long, long journey to get here. So like Yiğit mentioned earlier, at the time we even started considering, or at least apparently getting asked aggressively about Room getting to KMP, we didn't have any of the tools that we would need to actually get it there. So for the last couple of years, 3-4 years, we've been incrementally investing in building the tooling that we would need to even consider the conversion to Kotlin Multiplatform. So first of all, the very first thing that we had to sort out was we needed Room to be able to analyze Kotlin code, because it was at that time using KPT, the Kotlin Annotation Processing tool, which is dependent on the Java compiler. So we needed to add Kotlin Symbol Processing, or KSP support. This was followed by migrating all of Room runtime sources from the Java programming language to Kotlin, and teaching Room how to generate Kotlin code. So all of this tooling was each very specially worked on. So we should do a deep dive on them individually. And for that, Danny, can you tell us about KSP?
Yes. Hello. So as Elif mentioned, Room is an annotation processor. You write things, it has annotations, it grabs those annotations and generate code. And we had to develop multiple tools to support Java annotation processing, KSP2, and generate Java and Kotlin code. And one of those tools was X-processing, and we'll go through the rest in a little bit. X-processing, in essence, is just an abstraction over the Java annotation processing APIs and Kotlin symbol processing APIs. Now remember, Room generates code, but to do that, it has to analyze all your code. And in the early days, we had KPT, which you might not have the best memories of it. I don't, at least. And it was slow, it had problems. And KSP was a new tool that was developed to better process Kotlin sources, to understand them better. And it supported, or it had in mind since the beginning to support Kotlin Multiplatform. But because we really care about backward compatibility, we needed a way to support both backends at the same time, and that's where X processing comes in. And it really is very similar to the rest of the processing APIs. There's like a type that represents types. There's a type element represents interfaces, classes. There's a method element that represents function and methods. And we get to use these a lot. But let's just go through an example, and it'll make more sense. Going back to that sample database, when you declare your asset class, well, that is a type element within Room's view. When you have your DAO getters, those are the executable elements. When you annotate the database class, then that's when you have, and you pass your entities, that's when you have your types. So you can see, in essence, the X processing API, similar to KSP and Java annotation processing, has a way to represent the source in what we call an abstract syntax tree. Now, Room specifically, everything starts with a database. It's the thing that it first looks, and it reads the rest of the code, and it's able to generate that database implementation. So now let's go to Room's sources. We're in the compiler here, and we're going to try to implement a little bit of it. We all start with something we call a processing step. In essence, you have a callback process. This will get called anytime there's sources to process or things are being compiled. Now, in Room, we, again, specifically look for any type element that's annotated with that database annotation. Specifically, we are only interested in that abstract class. If you put the annotation on a method, if you could, then we don't care about those. And eventually, we just do some processing. And ultimately, we generate some code. But the idea here still is that thanks to X processing, we were able to just write this once. If we didn't have X processing, we would have needed to basically sort of duplicate this code, each with KSP APIs and with Java annotation processing APIs. Speaking of generated code, we also had a chance to develop, again, we use exploit to generate code, and that helped us generate Java and Kotlin code. But another example that X processing helped us was making decisions when we generated code. Going back again to the table, entity, there's a song ID on it, and Room, that song ID is like a column, and we need to read it. So we generate code for it. Now, depending on the code that we generate, the way you access that property is different. For Kotlin, you use a property syntax. And for Java, due to interoperability with Kotlin, you actually use a getter. So that was your entity. If you go back to our processor, one cool thing about X processing is you have a type element, you get all its method. It actually includes the getters of property. So again, here, X processing is helping us with the quirks between Java and Kotlin. We are looking for getters. They have no parameters, and they don't return unit or void. But the cool thing, again, about X processing is that based on what you're reading, whether it's Java or Kotlin, it also offers APIs to help us make those cogent decisions. In Kotlin, if you're generating Kotlin, we wanted to use that as property accessor if the getter came from a Kotlin property. And if not, then we can use that getter call. So as you can see, X processing is also giving us APIs to help with those different quirks and with the code generation. Elif knows more about exploit.
Which is code generation.
More code generation.
So I don't know if you mentioned it earlier, but Room originally also just generated Java code. And obviously, we needed it to know how to generate Kotlin code as well so that we could unblock ourselves in the road to multi-platform. So how we ended up doing this is when we finally decided, we have to resolve this problem at this point, we had two options. We could either add Kotlin Poet support So in addition to the Java pod dependency, we would depend on Kotlin pod as well, which would require doubling the number of writers that we had and just increasing our technical debt by a significant amount. Or we could go option 2 and come up with something that was a cross-language API that would mirror Java pod and Kotlin pod. So we went that route. And we ended up with Xpod. So what did that mean, mirroring both of them at the same time? Well, this meant that we had things like X type name, which represents a type name in Java and Kotlin, or X fun spec, which represents functions in Java and Kotlin. And for any other usages, we had X code block APIs, which did everything ranging from assigning a variable value to doing control flows like if-else statements, for loops, and etc. But we didn't actually stop there and just have it be a mirror. We took it one step further, and we added utilities so that we could make writing the code that generates code much easier for the developer experience. So let's look at a very simple example of what I mean by those utilities. So let's say you want to generate code that kind of looks like this. So you have a function that you're generating that returns the new instance of something. In this scenario, it's a DAO function. DAO, sorry. So when you look at the Kotlin and the Java outputs and compare them side by side, you see that the only difference here is that there's a new keyword required in the Java syntax, which is not required in Kotlin. It's a simple difference, but if you were to depend on Kotlin pod and Java pod individually, you would have to actually write code twice and generate them separately. So how do we handle this? So this is what I meant by that. So if you had Kotlin pod, you would have to implement it like this. If you had Java pod, you would represent it like this. And again, when you look at it, the only significant difference is literally the new keyword. And if you compare the rest of the API calls, the information getting passed around is exactly the same. It's just two different APIs. So what we did instead for Xpod is we do one function, and we take care of both scenarios. And how we do that is through xfunspec, which is what I mentioned earlier. So we have a builder that takes in a code language flag, the name of the function you want to generate, the visibility of the function, as well as the return type. And then you use the of_new_instance function from the Xcode block API, and it just takes in the code language flag. And it takes care of adding or not adding the new keyword for you. As you can see, this is way more concise than not only just having both at the same time, but just overall. So this was quite a simple example. So let's look at a little bit of a trickier example. So things get really messy when you're starting to use extension functions, because both languages very independently handle the scenario. So let's say you have this extension function, execute SQL, which, if you didn't guess by now, execute is an SQL statement. And we're going to call this function from the generated code. So let's see side by side what this would look like. So we actually use, almost happened. We actually use this in our code base in the auto migration writer APIs, and we use it specifically when we're generating the migrate function, which is the function that migrates your database from a version to another version. And it's a very simple function. It just has one parameter, which is the SQLite connection. That actually represents a connection to a database. And you're going to use that extension function using this connection as the receiver. So if you look at the Kotlin generated code, because it's Kotlin, you can actually call the extension function on the receiver. But in Java, things are a little bit more complex. You need to call the function from the class that's generated by the compiler. You have to pass in the receiver as the first parameter. So Xcode block and Xpod actually handles it very quickly and very easily for you. Again, we have a utility function called of_extension_call, and you just need to give it the language flag, the member name, the receiver name, and the assignment expression, and it'll generate that code for whichever language you're using for you. So in the road to developing Xpod, we had to make some design compromises because our goal, even in developing Xpod in general, was to have just a more concise way of writing code that generates code, which meant that in some cases, we would need to generate code that was Java-ish Kotlin, which means just less idiomatic Kotlin. And it's a A very common example of this from our generated code is when we have explicitly declared types for any variables that we might have. This is obviously not required in Kotlin. It doesn't have anything against it, but it's not required. But Java does require this, and if we were to generate Kotlin like this, it makes it so much easier to share the writer that actually does this. Another example comes in when we're doing for loops. So as you can see here, this is Kotlin code, and we could have easily used the for each index loop. It would have, been much nicer to write it, I guess. But it wouldn't be as compatible and as close to Java. So we instead use language for loops like this so that the code sharing is maximized and we don't have to write duplicate code. With that, well, we were done with Xpoet. So now that we had Xprocessing to analyze code, Xpoet to generate code, we really needed some form of strategy for testing code. And Danny had some interesting ideas on this.
I had some idea. I just wanted to delete all the tests, honestly, but Yiğit didn't let me. So we had to do a lot of work here. And essentially, we just created yet another tooling API here. This time, we call it Xprocessing testing. And essentially, it just helps us test the various permutations that we have, generating Java, generating Kotlin, KSP, KPT, Java C. This was really important for us, though, not for me, for the boss, but I guess for me too, because we had all these tests already that verify processing Java, and including some tests in KPT, and now we were going to convert those to using KSP. So we really wanted to have a consistent test, and again, to ensure that backward compatibility. It also made our code way more maintainable because that means we didn't have to repeat the test in every backend that we supported. Let's go through an example. Xprocessing testing is a compile testing API. You define sources, you run the API or run the test, and it'll actually grab those sources, compile it with Kotlin C or Java C, run the processor, and output some information. So let's do a test. We start with our Kotlin source here. It's a database, very similar to our example app at database, an abstract class. The important here on this source is it's not extending Room database, and that's important for Room, and we actually have a check for it. So this test is about making sure the user extends that class. As an example, or entity will write it in Java. This is me just showing you that you can use both Kotlin and Java sources. Now, on the actual test, the API that's from Xprocessing testing is called run processor test. You give it the sources, give it that processing step that I showed you earlier, and it's, again, going to run and compile. And then at the end of it, you get this lambda where you can verify certain things. In this case, we are making sure that an error is raised because that database annotated class does not extend Room database. And again, the cool thing about it is that it will run, in this case, because a single Kotlin source was given, it will run on KSP and KPT. If you give it only Java sources, it'll run on KSP and Java C. And that really helped us. And I think it's cool too.
Well, with that, thankfully, we could do testing because Danny didn't let Danny delete the test. But at that point, we have our processing environment sorted out. We can generate code in whatever language we want. Well, we wanted Kotlin for Multiplatform, but obviously. And we have testing all sorted out. So we're ready to go to KMP, right? No, we're not. There's still a huge piece of the puzzle that we hadn't figured out yet, and we really, really needed to, which was how were we going to use SQLite APIs from multiple platforms? And Danny's going to talk a little bit more about that.
Yep. Here, Room and abstraction over SQLite, underneath all the runtime code generation, it does use Android's SQLite APIs. And of course, those are not available for KMP, so we had to do something about that. And here, there were a lot of changes that we had to do not only in Room, but in our infra, just like Yiğit mentioned. And I'll mention some of those here, some of the highlights. One of the cool things we did was, because we wanted to create a SQLite KMP library, we actually decided to use Kotlin native CLang, the same CLang that ships with Kotlin native and its system roots to cross-compile SQLite. This was just to be good for CI and to have the most compatibility with other Kotlin KMP code. Kotlin, as you know, is very cool, and it offers a C-interrupt API. SQLite is basically a C library, so thanks to the C-interrupt available, the new memory model, and those things, we were able to expose SQLite C APIs within our Kotlin code. We also wanted to develop a SQLite KMP library that was flexible, so we opted for actually developing 2 versions of it. One, we call it the bundle, which includes SQLite. It supports Android, iOS, JVM desktop, and then we also made one called the framework SQLite, and this one uses Android APIs for Android, native iOS directly with SQLite. The library as a whole, we call it the SQLite driver. So one of the missions here was to create it and then migrate Room into it. Let's go through a quick sample of how would that look. Room runtime is the runtime version of Room. It depends on SQLite framework. This is the one that in Android, it will go all the way to using the SQLite database class when you use the Android SQLite driver, when you configure Room with that driver. On the other side of things, in iOS, we have a native SQLite driver. It will talk to SQLite directly, because iOS being a native library, it can talk, you can link to it and talk to it with the headers. Now, those are Android and native only, or you can only use it in the native sources and other sources, but we wanted a common one. And for that, we created Bundle SQLite. You can use it for common, and it'll like figure out who to talk to. On Android, JVM, it'll use JNI, and on iOS, Linux, Mac, it'll use the SQLite tree that was compiled with it. And with that, we have a SQLite KMP.
Yeah, well, at that point now, we had the drivers, so all we had to do was just migrate to the drivers, generate cross-platform compatible code, and then we were done, right? Well, no, wrong. Like I said before, Room was an originally Android-only library, so we really needed to make sure that we didn't break our existing users, which is millions, in the millions, which is crazy. And I want to do that, similar to how you want to set the test on fire. But he told us we can't, so like, I was not allowed to. But how did we end up maintaining compatibility when we were making these extremely large changes? Well, we first set out by serving all of the Room APIs. We went through all of the code and identified anything that could be moved to common from the get-go, which we did immediately. And then we left anything that was Android-only functionality on the Android side of things, making sure that our existing users were not impacted. And then for anything else that was remaining that could be moved to common, but we needed some way of actually making that happen, we developed strategies on how we could do that. So let's go through those strategies a little bit. So the very first strategy that we came up with, and we ended up using a lot of, was to use expect actuals. So the really cool thing about having expect actuals is that you can have the expect class declared in your common source, and it can be called from other common places, but then you have the opportunity to use the actual to implement individual logic for each of the platforms. So a very good example of this, and a very big point of divergence between platforms and how they handle it, is how file input-output is done. So an example from our code base is the file lock class. So what does the file lock class do? It locks the database file when you're opening the database, for obvious reasons. And obviously, it differs very differently in implementation between the different platforms. So when we look at the native side of things, how native does this is it uses POSIX, and how Android and JVM use this, how Android and JVM implement this is by using NIOs and channels.
I'll take the other strategies. The other thing we did use expect actual a lot, but we also just created common interfaces and implemented them. And this was very helpful for the driver, because you can have these interfaces in common code, all your common code uses them, and then you can provide more than one implementation for the same platform. So like we mentioned earlier, the Android has the bundle SQLite driver, but you can also use the Android SQLite driver. And this works well for new APIs, and An example of that, again, is the SQLite driver. We defined those interfaces in common, and then we went ahead and implemented multiple versions of them that can be very different. In this case, like the native SQLite driver uses cinterrupt. Meanwhile, we also have the bundle SQLite driver, and the Android JVM version of it, at least, is very different, and it uses JNI. So this gives you like an idea of a strategy you can use when you have a new API. Now, for assisting APIs, we had to employ other strategies. One of those was just creating top-level common functions. I'll walk you through an example. In Room, we have this table info. It represents some data of a table. It has an equals and hash code. And this class, if you look at it before the KMPification, it was 99% code that could have been common, but it had a single API that was in Android. We couldn't move it, so we ended up creating expect actual. But because we didn't want to duplicate implementation, what we ended up doing was creating top-level functions internal that had the body of everything that was common, that equals and hash code. And then in each platform, we then just delegated to those common code, and we just, in the Android version, we were able to keep the Android-only API. So this was very helpful for maintaining that backward compatibility. It goes without saying, we had a bunch of other problems that we don't have strategies for. One of those was we heavily use Java concurrent APIs, executor, runnable, scalable. For that, we just went ahead and started to use coroutines. I don't have a strategy here. It's a very case-by-case basis, but at least the important thing is that we wanted to keep the behavior the same. And even though it's a technical hard problem to solve, it was extra problem, at least for us, due to our backward compatibility requirements. Other interesting that we did, we were able to also create new APIs, or we decided to create new APIs when it made sense. One of those was we have a little bit of reflection in Room when it finds the implementation, and I'll walk you through an example. And for that one, we opted to create a new API so that we could provide the best experience for each platform. Java, Android using reflection, and native not using it. And I'll walk you through the example. Something we didn't mention earlier is how do you instantiate a Room database? Well, we have this builder that you use. And the important thing here is that you give it the database class. And that's the add database annotated class that you created that Room creates an implementation. In Android, you give it a context, and then you build this thing, and it'll give you an instance of the music database. Now, the way it works is it uses reflection. It has a class for name. We grab the class, we concatenate it with underscore input, and that just happens to match with our annotation processor code and the generic database implementation, and that's how it finds it. Now, the tricky thing is that there's no reflection in Kotlin native, right? So for this case, we just had to create a new API. It's not great. You pass a lambda, and this lambda then directly invokes the constructor of the generated code. We don't like it because it's not a great user experience. If you haven't built, you'll see squiggly red lines and types not being resolved. And then sometimes you build and you'll be able to get it. So it's not the best, but it's how we were able to get things working on native, but yet on Android JVM, reflection is there and we provide the best experience. So part of all this process is having that goal of providing the best experience for each platform. So if there's ever a KMP reflection library, let me know, because I would use it, I think, a bit. And that's it. That's after all that trouble, we were able to get Room KMP. Woohoo! Thank you.
Thank you. And so that was a lot of work, and we also wanted to show you like a little bit behind the scenes what it takes for us to bring a library. Luckily, not every single library is this complicated, but it was also nice for us to do this. And like all the code we have shown, they're not necessarily libraries, but it's all open source that if you have similar needs, you can use them from our code base. So the main takeaways from this presentation is like, first of all, the Room KMP stuff, it is not feature complete. So we have a couple of things that are only on Android, but we will keep working on them. So the alpha version, we have most of the functionality we wanted, and a couple more will come in the following alpha versions. Right now, we support JVM, iOS native, Linux native, Windows Other, but we don't support web yet. We want to add WASM support, so hopefully that will also come later. But the main takeaway is we will keep doing this to many of our Jetpack libraries where it makes sense. So if you're already using Jetpack and you want to use Kotlin Multiplatform, let us know, and we will do prioritization based on it and try to expand KMP. Well, you can go to that link, try and start converting your app to KMP. And also, if you enjoyed this talk, please go and vote. If you didn't, please don't. Otherwise, they will not invite us next year. But thank you. I did the hard part. We have 4 minutes for questions. Also, we'll be around.
It was crystal clear. No questions.
Easy.
No question.
Okay.
Such a good presentation.
We'll see you around.
I think there's a question.
Okay, yeah. If you have a question, please keep your hand up.
So you had to see.
Sorry that I have a question not specifically for Room, but for the concept of view model. Why is that for iOS you need to transfer the concept of a view model for the Jetpack library, for the multi-platform? Yeah.
Wait, sorry. Can you repeat? Why do we have to do it?
Yeah, because specifically in the iOS world, I think view model is not really the concept, I guess.
Yeah, so there's actually something. I mean, we have Marcello there. You can grind afterwards. But what we are basically trying to do is we have all this developer ecosystem that wants to reuse as much as they can. And like based on talking to developers, they actually they really want to reuse it. Like your screens they might look different. That's why we recommend native UI, but the contents are more or less the same. And on Android, for most applications, it lives in the view model. So we kind of want to make it, okay, you can reuse it. It's not necessarily, like, we're not going to be honest, like we don't know the best practices for iOS app development. So we will learn with the community, see which one sticks, and see if we need to change view models to be more cross-platform compatible. So we are very open, like we are aware where we are.
Okay, thank you, and thank you also for the talk.
There's a hand on the back.
Oh, thank you all for the brilliant work on Jetpack KMP. So Compose multi-platform. It feels like JetBrains built this without Google being involved, really. I'm not sure. Is there interest in working to bring Compose multi-platform to work really well across all the platforms?
We run out of time, sorry. It's complicated. We are actively working with JetBrains on that, but yeah, this is a JetBrains project. They're pushing it. Compose is super important for us. So these two companies collaborate a lot, but it's complicated. I don't want to get fired. So, good job.
Me neither.
Okay.
Oh, there's one question over there.
Over there.
I think, yeah, last question.
Okay.
Last
You
question.
have 55 seconds.
Go. No French.
52 now.
This is going to be like a little bit like going to how you started this talk, but are there any plans on Work Manager going multi-platform?
I want it, if I can convince the team. We don't know yet, but I think it is one of the libraries that could make sense. But also, like, Work Manager on the Android side is very complicated, and we work with the Android job scheduler team a lot. So if you want to do multi-platform, how are we going to do the same things on iOS is something we don't know, and we don't yet have the time to investigate. So I think it's quite possible, but not necessarily the highest priority, let's put it that way.
Okay, thanks.
Right. Thank you, everybody.
Thank you.